and today I'm joined with Juan Valverde from MathWorks. Thank you so much for joining me today, Juan.
Thank you. Hello.
So to start with, how have we seen the virtual testing landscape evolve in recent years, and what do you think is driving this development?
Yes, so this is a very important question. So the thing is, we are going towards the design of more and more complex systems, right? So, and then we are very challenged by the having to have things right at the first time. We are very challenged in the design, for example, of autonomous systems, right? So we have to, we need a lot of data to get things right. And because of costs and time, we are now in a more competitive environment. So we need to really get things tested before things get to the final hardware. So it's a very challenging thing. So yeah, I think it's a great moment for tools and for methods like this. So yeah, I think it's good.
And then building on from that, how can new methodologies adapt to the increasingly complex environment that we're seeing?
Yes, so from everything that I had said, I think modeling and simulation is the key. So you really want to have things, like I said, tested before you actually have to go to the hardware at the end. If I'm working with an engine, you really want to try to test things before you actually have the engine built, right? So it's very important. So for that, it's like I said, modeling and simulation is very important. Now, in order to do that, you can work with different levels of fidelity for these models, right? So you can start with something that is very, like the fidelity is very low, it's very simple, and then you have to start moving to something that is really mimicking what the final system will do. Doing that is not easy, right? And this is one of the things that we're working on at all, right? Which is we are trying to get these technologies so that we can have these types of models. Another thing is the collaboration. We see a lot how it is not only I need to get things tested at the end, I am collaborating with other people. So we see a lot of more collaborative environments. So I need to give you things tested before you can actually integrate these things, right? So that's why this is evolving. Yeah.
Absolutely, and we've touched on it a little bit already, but in terms of advanced tech supporting the industry, how can this help when it comes to the design and verification process specifically?
Yes, so at the end, it is very important to understand the role of, normally in many companies, we have the role of a process, methods, and tools. So finding these proper processes and methods, right, and using the right tools to do that is very important. Through that, it is possible to enable the different design and verification teams so that you can actually get there. So you can actually, having the support from these teams, you can get to the having the right level of modeling, the right level of data. We're in the era of data, so everything is data. How can we convert this data into something that is usable? And then the tech support is very important to do this, right? We have to provide the design teams, like I said, of these the right methodologies to do things. So it's very important.
That makes perfect sense. And then, in your opinion, where are the biggest gaps in the current aerospace testing methodologies and approaches, and how do you think this is changing?
Well, I'm not sure if it's changing, but we can definitely, we're pushing for that. I would say that the main gap is that even though we are talking about very advanced things, the reality of many of these companies is that they're still, design workflows are still very paper-based. They are like iterations, like I do something and then I find something and then I have to go back to fix it. They're really slow. Different teams are working in isolation. So they have these silos. So it's very difficult for me to identify an error to testing that is depending on something else that I will have to integrate somewhere at a later stage. So for me, this is a very big gap. Also, the approach of what is now very in fashion, which is the systems engineering approach, right? So normally, in the past, we always had this approach of, I am designing my system, and whenever this system is done, I will give it to you. you integrate it, and then hopefully it works. The reality, it never works. So you require a lot of iterations. When the teams are small and systems are not that complex, this is a waste of time, but okay. But as we go and the complexity increases and we have multinational teams, multinational consortiums working with that, this is completely unacceptable. So you have to have a systems engineering view so that you foresee how things need to be integrated, what are the different contracts among the different parts before you get there. This is very important. We see this growing. I hope we are improving and solving this, but I think it's a bit still down the line.
Yeah, and that's quite a significant challenge and mindset to make
Yes.
that shift as well. So
Yes.
naturally, it might take
Exactly.
a bit longer.
We need an investment, a time investment, to change the methodologies, and this requires changing the teams working on these projects as well, which is not easy. You have to reallocate people, you have to move people, so it's not.
Of course. And then why did you decide to join us at Aerospace Tech Week Europe today?
Well, I mean, we are very interested in meeting new people, of course. We are interested in knowing what is happening, how all these methodologies can be applied to real life, right? Like I said, so we have many customers working with us and our tools on these. We'd like to continue expanding that, understand the gaps once again, and how can we cover these gaps, and to build relationships and to continue working. So
Fantastic. Well, thank you for joining me today, Juan.
thank you.